All right, in this video we're continuing with section 7.7 for Precalc honors. We're talking about the determinant of a square matrix. So when we're talking about a determinant, we're looking at the coefficient matrix here. So we're just pulling off the coefficients from our system. And the determinant then, which we talked a little bit about it in the previous video, is going to be the product of this diagonal of values minus the product of this diagonal of the matrix. So we've got the determinant of A is A1 times B2 minus A2 times B1, and we'll sometimes use these absolute value bars to show the determinant, so you just need to know from the context of the problem. So sometimes you'll see it as the determinant of A is equal to, and then instead of putting the matrix brackets here, we just put the absolute value bars, and then we'll do A1, B1, A2, B2. And when you see these bars, you know we're talking about the determinant. So vertical bars indicate determinant. Determinant. Okay, so let's take a look at an example. Find the determinant of each 2 by 2 matrix. So I will expect you to know how to do this without a calculator. Again, I won't have you do anything larger than a 3 by 3. You'll see that a 3 by 3 is a little bit more labor intensive. So the determinant of A, just following the formula up above, so we're going to multiply these two. So I have 2 times 5, and then subtract the product of those two, 3 times negative 1. So that's going to be 10 plus 3, or 13. If you want to pause the video and work out part B, feel free to do that. I'm just going to work it out here. So the determinant of B, again, the product of these two, it's going to be 3 times 2 minus negative 2 times negative 3. So that's 6 minus 6, or 0. So pretty straightforward for finding the determinant of a 2 by 2. If we want to find the determinant of a 3 by 3 matrix or higher, we're going to need to use the idea of minors and cofactors. Okay, these are very similar concepts, so if you're having trouble distinguishing between minors and cofactors, make sure you get some help. So minors and cofactors, if A is a square matrix, the minor M sub ij, so this is just an entry, I and j is just an entry in the matrix, of the entry A sub ij is the determinant of the matrix obtained by deleting the ith row and the jth column of A. The cofactor C sub ij of the entry A sub ij is given by C sub ij is negative 1 to the I plus j times M sub ij. So this sounds kind of complicated. The process, it's a little bit involved, but really it's not that difficult. Again, the minors and the cofactors are very similar. So once we find the minors, which we're going to do by finding determinants of 2 by 2 matrices, then we just assign them a sign based on this table of alternating positives and negatives. Okay, so and you'll see it when we do an example. It's really not that difficult. Again, it's a little bit labor intensive for anything bigger than a 2 by 2. So let's find the minors and the cofactors for this matrix, and then once we do that, in the next example, we'll find the determinant. All right, so let's go ahead and find the minors first. So each one of these entries is going to have a minor associated with it. So the minor for entry 1, 1, that's the 3. So when we're finding the minors, we're going to cross out, since we're working with this 3, I'm going to cross out this row, and I'm going to cross out this column, and I'm going to define the determinant of this matrix. So it's going to be the determinant of the matrix that's left over. So it's 2, 1, 3, and 6. So that's going to be 12 minus 3. So that's going to be 9. All right, then let's move on to the minor for row 1, column 2. So row 1, column 2. So I'm going to cross out row 1 and column 2, and I have these 4 values left here. So I'm going to find the determinant of those values. So determinant of 3, 1, negative 1, 6. So that's going to be 18 minus negative 1, so that's going to be 19. All right, then we're going to do the minor for entry 1, 3. So row 1, column 3. So I'm going to find the determinant of 3, 2, negative 1, 3. So that's going to be 9 minus negative 2. So that's going to be 11. All right, so that takes care of the first row. Now we're going to start with the second row. So I'm going to start with this entry. So I'm going to cross out everything that's in that row and column. So I'm going to find the minor for row 2, column 1. So I crossed out row 2 and column 1. And the entries that I have left are negative 2, 4, 3, and 6. So we'll find that determinant. So it's negative 12 minus 12. So that's negative 24. Then we're going to do the minor for 2, 2. Then we'll do the minor for 2, 3. So now I've got this entry. So let's cross these out. And I'm going to do the determinant of 3, 4, negative 1, 6. So that's going to be 18 plus 4. So that's 22. All right, moving on to the next entry. So cross out that column and that row. And what I have left is 3, negative 2, negative 1, 3. So that's going to be 9 minus 2. So that's going to be 7. All right, we're almost there. Next row. So this is row 3, column 1. So I'm going to cross out these two. So I've got the minor for 3, 1. And then I'll have the minor for 3, 2. And then I'll have the minor for 3, 3. So just getting ready there. So for 3, 1, I've got negative 2, 4, 2, and 1. So that's negative 2 minus 8, which is negative 10. And then for 3, 2, that's this entry. So we'll cross those out. And I've got 3, 4, 3, 1. So that's 3 minus 12, which is negative 9. And then the last entry over here. So I'll cross out that row and that column. And I'm left with 3, negative 2, 3, 2. So that's going to be 6 plus 6. So that's 12. All right, so we have all these minors, and now what we need to do is change the minors to cofactors. Now, the only thing we need to do to change these to cofactors is apply the appropriate sign to each value. Okay, so this plus means that that sign is going to stay the same. That minus means that that sign is going to change to the opposite for each of these minors. So for my cofactors, so let's just write down our table here. So it's plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so I'm going to have a cofactor for 1, 1. That's going to come from the minor from entry 1, 1. So that stays the same, so that's going to be 9. And then cofactor for 1, 2. So that's this entry here. So row 1, column 2, that's going to change to the opposite. So that was 19. Now it's going to change to negative 19. And then the cofactor for 1, 3, row 1, column 3, that's going to stay a plus. So that's going to stay 11. And then we're going to have cofactors for 2, 1, 2, 2, 2, 3, and then cofactors for 3, 1, 3, 2, and 3, 3. All right, so for 2, 1, row 2, column 1, it's going to change to the opposite. So that's going to be positive 24. For 2, 2, that's right in the middle, so that's going to stay the same. That's going to stay 22. This one is going to change to negative 7. Okay, it's this one here, negative. And then row 3, column 1, that's a plus there, so that's going to stay the same. That's going to stay negative 10. I just want to reiterate that the pluses and minuses here really tell you if you're going to keep the sign the same or change it to the opposite. All right, row 3, column 2, it's going to change to the opposite. So this negative 9 is going to change to a positive 9. And then 3, 3, positive, that's going to stay 12. So these are my cofactor values. And again, the only thing that differentiates these from the minors is that we're changing their sign based on this pattern here. All right. All right, so we'll end this video here, and then in the next video we'll take a look at how we're going to use cofactors to actually calculate the determinant of a 3 by 3 square matrix. And again, 3 by 3 is probably the largest I would ever ask you to calculate by hand. Otherwise I'd have you use a calculator. If you have any questions, make sure you get those answered, and we'll see you in the next video.